This is part 3 of the bicycle frame video. In part 2, we completed steps 1 through 4 of the bike frame master file. Step 1 was to insert our geometry file. Step 2 was to use the geometry file as an underlay for making our main front layout. Step 3 was to make a detail layout of just the cross section of the head tube. And step 4 was to make a detail layout of just the rear dropout plate. In this video, we will be covering steps 5 through 8. Step 5 will be to make a tilted plane passing through this geometry line for the chainstay. Step 6 will be to make a tilted plane passing through this geometry line of the seat stay. Step 7 will be to draw a tilted layout for the chainstay on the plane created in step 5. And step 8 will be to create a tilted layout of the seat stay on the tilted plane made in step 6. We will finally start making some solid geometry in step 9, which is in the following video. Making the solid geometry should be relatively easy if we've gotten steps 1 through 8 correct. One of the key issues is making sure that all of our layouts, especially these tilted layouts for the stays, are properly aligned with each other and with the front main layout. Being sloppy is going to lead to a lot of problems. Taking the time to get these alignments correct now will make things a lot easier when it's time to make the actual frame. I will now roll back to step 4 and recreate steps 5 through 8. Step 5 is the plane tilted through the chainstay. Selecting reference geometry plane, I'll select my front plane as my first reference, and this geometry line is my second reference. That will make a new plane perpendicular to the front plane and tilted. Step 6 is a similar procedure. Going to plane again, we will again select our front plane as the first reference, and for a second reference, we will select this geometry line going through the layout. That will make a new tilted plane for our sketch for the seat stay. I've just made my planes visible so I can see my rear dropout plane, my tilted plane for the seat stay, and my tilted plane for the chainstay. Step 7 will be to draw the layout sketch on the tilted chainstay plane. First thing I'll do is draw a representation of the dropout plate when viewed from this orientation. The dropout plate just looks like a rectangle when viewed from the tilted plane. And I need the inside edge of the dropout plate to be even or collinear with this rear dropout plane. So I'll click on this line and the dropout plane and make those collinear. Then I'm going to add a dimension to the width of my plate. I'll make this 7 millimeters. You can make that thicker if you want, but if you make it too thick, then your axle on the rear wheel will be too short and you'll have to go back and change the axle. Now I am going to hide my planes just because they're obscuring my view too much. I want to take the ends of the plate and align them with the ends of the plate in my front view. The easy way to do that is draw some construction lines that are going vertical, and I can make a coincident relation between these endpoints and the points that represent either end, the dropout plate in the front plane. So I have a choice between aligning this point with either this or this point. I'll just make a coincident relation to the top point. And for this point here, I can choose either of these 2 points. So I'll make a coincident to this top point. Now the plate, when viewed from that tilted plane, is fully defined. I'm going to add a center line that's going to go from the midpoint of this line to the midpoint of this line. That exactly is on center now with the plate. And that will be helpful when I draw my curves for my chainstay. While I'm still at this end, I'm going to draw the line that correlates with this line in the front view sketch. This line will be the end of the chainstay. I will add a point on the midpoint of that, make it coincident to this center line. And I'll make that about 14 millimeters wide, so that's how wide the chainstay will be at this end. And I need to align this line with this line. So again, using this trick of adding a little construction line that's vertical and making it coincident to any of these 3 points, because this line is perpendicular to my sketch plane. And I'll have this line in alignment with this line here. My sketch is soon going to be cluttered with relations, so I'm going to turn those off. Now I'm going to move to the other end of the chainstay, which of course is at the bottom bracket shell. I didn't do this in the example file, but what you might want to do is draw a depiction of the bottom bracket shell also in this view, so that you know when you attach the chainstay to it that it's not too wide or too narrow to attach to the bottom bracket shell. So I'm just going to draw a rectangle here, and I'll make a pierce between this point and this circle here, and a pierce between this point and the same circle. So that will cause this circle in my front layout to drive the width of my rectangle in my tilted top layout. I happen to know that the bottom bracket shell should be 68 millimeters wide. I'm going to turn this into a construction line, and I will just add a dimension from here to the center line, and then pull off to the side so that I get the full double dimension of 68. Now I can start drawing this end of the chainstay. We can see in the front view that the chainstay is passing through the center of the bottom bracket shell. So we will do the same in this view as well. I'm going to draw a center line, going to the center of the bottom bracket shell, which also happens to be our origin. I'll just drag this out to here. Now I can start drawing the guide curves for the chainstay. So I'll first draw a line representing the width of the chainstay at this end, and I'll draw a center line on that going to the midpoint. And I'm going to dimension the center of that stay to this line here. I'll make that about 20 millimeters from the mirror plane, which is the front plane, and I'll make the stay about 20 millimeters wide at this end. This will be the end of the chainstay, and we can see that it is inside our bottom bracket shell. Now I can start drawing some splines that connect this end to this end. So I'll start with the inside guide curve going from this point here to this point here. I'll draw the middle guide curve, which actually represents the upper and lower guide, going all the way to this point here. Finally, the outer guide going from here to here. Right now these look like straight lines, and I'm going to start tweaking my handles for these splines. Drag this handle out. I'd like the direction of my chainstay to be going in the same direction as the plate when it meets the plate. So I will add a horizontal relation to this spline here, horizontal to this one, and a horizontal to this one. This way it turns the corner and is going in the same direction where it attaches. At this end, I could just leave this the way it is, although we see that this is getting outside of the shell. So I can start tweaking these curves too to create kind of a nice S curve. If I want, I could make these horizontal as well, although it's not as necessary. You want to make sure that the chainstays are far enough apart so that they don't rub on the tire, which is going to pass through in this area. I already happen to know that this is going to work okay, but you might want to use the same technique you used on the bike fork, where you made your front sketch from the inserted file visible. Here we see the tire. And then you drew a circle representing the tire about 25 millimeters in diameter. Added a sketch point here. Pierced this point to the tire. And here we can see that we're okay, that the tire is going to miss the inner edge of the chainstay. So I can make just a little bit more clearance here if I want. And I'll make this a construction line. I don't believe this is in my sample file. Here's what that sketch looks like from the top view. We'll zoom in on the back end and rotate so that you can see how the alignments are made between the front main layout and this tilted chainstay layout. Zooming in on the bottom bracket area, we'll rotate that once again. We can see how this representation aligns with the bottom bracket shell in this view, and we can see how the end of the chainstay here aligns with the end of the chainstay in our front layout view. That completes step 7. For step 8, we will be doing the same thing for a seat stay. We are going to be drawing that on our tilted plane made in step 6. So making a new sketch, we'll start once again with the depiction of the dropout plate when viewed from this tilted plane. So once again making a rectangular shape. We can make this line coincident with our rear dropout plane, actually collinear. And we can make this line coincident with this point in our chainstay sketch. I want to align the top with the top here and the bottom with the bottom here. So once again using our trick of adding a center line. This time they'll be horizontal. This top center line needs to be aligned with this line here. The best way to do that in this case is to use a pierce. So just click on this line, click on this point, and make a pierce. Down here, this will need to be aligned with this line here, and again, we'll click on this point and this line here and make a pierce. So this is what the shape of the plate looks like if we're cutting through this shape here on a tilted plane. Draw another center line going from midpoint here to midpoint here. That will be helpful to us when we draw the actual curves for the seat stay. Draw another horizontal line here. Make a midpoint relation. Make that point coincident to this line. And this line is going to represent the end of the stay itself. This is the end of the plate, this is the end of the stay, and I'm going to make that about 12 millimeters wide. And because of this midpoint relation, it is centered on the plate just like it was down here. This needs to align with this end here. So once again, using a construction line, dragging this out horizontal. Here I have an actual convenient point on this line that I can make a coincident relationship to, or I can again click on this line and make a pierce relation to this point. In this case, either is going to work. So I'm just going to click on this point, and coincident. We've got the end of our stay in the right position, and we can go work on the end that intersects with the seat tube. Zooming in here, You see, here's the end for the seat tube. So I'm going to draw that end as a horizontal line in this view, and I need to make this line align with this point. Making a construction line, drag this out, make a coincident between this point and this point. So that sets this location. Now I can start drawing my curves that will bridge between these two ends. Again, I'm just going to draw some simple splines. This one will go to the midpoint of this line, and the last spline will go from here to here. Going back to the top of the seat stay, I need to make sure that this is coming in close enough to the seat tube so that it's completely intersecting the seat tube. So one thing that could be helpful is draw what the seat tube looks like when it cuts through our sketch plane. The seat tube is round in cross section, but if it's cutting through our sketch plane, which is cutting through at an angle, that tube will appear as an oval in this sketch. So I'm going to draw an actual oval, and I'm going to pierce this point to this leading edge of my seat tube. And I'll pierce this point to the trailing edge of my seat tube. So that sets the length of that oval. And then I know the width of the oval should be 32 millimeters because that happens to be the diameter of my seat tube. So this is the shape of the seat tube when it passes through our tilted plane. We can see that the top of our seat stay is way outside of this, so I'm going to drag this back here inside the tube. I'm having a little difficulty doing that, so what I'll first do is add a dimension to the width of the stay at this end. I'll make that about 13 millimeters. That makes it a little easier for me to drag this over. And I bring this so that this entire end is inside this oval. So I'll just add a dimension from this point to the center of my stay, and I'll make that about 8 millimeters. And I'll change my oval to construction so it's a little less distracting. So here we can see a full intersection between the seat tube and the stay, so we know that when we make this, it's not going to be hanging out accidentally. Zooming out a little bit, I see that this is just straight lines right now. That's okay for your design, but I made these as splines, so obviously I want to curve these a little bit. So I'm going to curve this out on all three curves. And I would kind of like to have these going in the same direction as the plate is when they meet the plate. So that means in this case I'm going to add a vertical relation to each of these handles. And I think I'll just let this end be as it is. So you see this gentle bowing out of the seat stay when it goes from the seat tube down to the dropout plate. Again, we can see these critical alignments. Here's my dropout plate aligning with my sketch on the front plane. Going back up to the top, I can see how the top here is aligning with the front plane sketch. You can see how this oval is the width of the seat tube when the seat tube is cut by a plane on an angle. That completes step 8. And if we've done everything correctly, all these sketches will be in perfect alignment with each other, and we are then ready to start making solid geometry.